Hi everyone, myself P. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about my topic is linearly independent and dependent of vectors. Already I discussed in the last classes what is linearly dependent and independent. Linearly dependent and independent means independent means if det A not equal to 0, if determinant of A not equal to 0, we have to consider the given matrix or given vectors are the linearly independent. Linearly independent. If det A is equal to 0, then the given vectors are linearly dependent. This is the concept for the linearly independent and dependent. Okay, I will start with the first question. Show that the vectors 1, 2, 3, 3 minus 2, 1, 1 minus 6 minus 5 form a linearly dependent set. Okay, we have to show that the given vectors are linearly dependent. For that, first we have to arrange the given vectors as column wise matrix. Column wise matrix. For that, what about the first column there? First column, that is x1 is equal to 1, 2, 3 and x2 is equal to 3 minus 2, 1 and the third vector x3 is equal to 1 minus 6 minus 5. Okay, this is the vectors x1, x2, x3. Write it as the given three vectors as three column matrices, that is x1, x2, x3. The vectors x1, x2, x3, after writing it as in column matrices, write it as one square matrix. Write it as in one square matrix, that is write it as first column as first column in matrix and write it as the second column as the second one and third column as the third matrix, third column, right? This is after writing it as x1, x2, x3 as one matrix form. This is 3 by 3 matrix. The vectors x1, x2, x3 form a square matrix. This is one square matrix. For that, we have to find determinant value. Determinant value. For that, I am taking whatever the question there. Given matrix A is equal to 1, 3, 1 and the second one 2 minus 2 minus 6 and the third one 3, 1 minus 5. For that, we have to find det A value. Find det A value. For that, det A is equal to, already we know that how we are finding the determinant value. For that, 1 into neglecting that corresponding row and column and the remaining matrix minus 2 into minus 5, that is 10 minus of minus 6. Next, minus 3 into neglecting the corresponding row and column. For that, 2 into minus 5 minus of minus 6 into 3 plus 1 into, what about the next one here? That is neglecting the corresponding row and column, that is 2 into 1 minus of minus 2 into 3. Okay, this is the matrix determinant. For that, okay, here 10 minus of minus 6 plus 6 minus 3 into here minus 10 minus of minus plus 18 plus here 2 minus of minus plus 6. Okay, from that 10 plus 6 is 16 minus 3 into minus 10 plus 8, that is 8. Okay, plus 8, that is 6 plus 8, 16 plus 8, sorry, 16 plus 8 is equal to 24 minus 3 into 8 is 24. Okay, therefore after finding the determinant value, if it is 0 or not equal to 0, this is equal to 0. Therefore, det A is equal to 0. Therefore, the given vectors are linearly dependent. What they are asking in the question, show that the vectors are linearly dependent. After finding the determinant value, here we get directly that is equal to det A value is equal to 0. Therefore, given vectors are linearly dependent. This is the concept for the first question. Similarly, one more question from that. Show that the vectors show that the vectors x1 is equal to 2 to 1, x2 is equal to 1 4 minus 1, and x3 is equal to 4 6 minus 3 are linearly independent. We have to follow the same concept for this also. First we have to write it as the given vectors as column wise matrix. For that, here what about x1? Given vector as write it as first one column matrix, that is 2 minus 2 1, and x2 is equal to 1 4 minus 1, and x3 is equal to 4 6 minus 3. Write it as that x1 x2 x3 columns are okay, vectors are column wise matrices. For that, we have to form one square matrix from the given column matrices. That is x1, x2, x3, x1, x2, x3. For that, what about the matrix for that? First, write it as first column 2 minus 2 1, second column 1 4 minus 1, third column 4 6 minus 3. This is the matrices for the 3 by 3 matrix. For 3 by 3 matrix. For that, we have to find determinant of A value. If det A is not equal to 0, therefore the given vectors are linearly independent. If det A is equal to 0 means that are linearly dependent. Here once observe, okay, for that first we have to verify determinant of A value. Determinant of A. For that det A is equal to, okay, then 214 minus 246, 1 minus 1 minus 3. For that I am finding determinant of A value. For that, what about the matrix? 2, 1, 4, next minus 2, 4, 6, next 1, 1 minus 1 and minus 3. For that I am finding determinant of A. What about det A? Det A is equal to, for the first element, 2 into, okay, neglecting the corresponding row and column. For that 4 into minus 3 minus 12, minus into minus plus 6, minus 1 into, okay, neglecting the corresponding column and row, minus 2 into minus 3 minus 6 into 1 plus 4 into minus 2 into, okay, minus 1. This is minus 1 minus 4 into 1. 4 into 1. For that here 2 into, okay, after subtracting minus 12 plus 6, that is minus 6, and minus 1 into plus 6 and minus 6 plus 4 into, this is 2 minus 4. This is 2 minus 4. For that, this is minus 12, this is minus 12, and there 6 minus 6 cancel, and this is plus, wait, minus 12 minus 1 into 0 plus 4 into there minus 2. That is minus 12 minus 12 minus 8. Minus 12 minus 8. This is equal to what? Minus 12 minus 8 is equal to minus 20. Therefore, we get the det A value as minus 20. If it is 0 or not equal to 0, this is not equal to 0. Therefore, the given vectors are linearly independent. There, det A not equal to 0. Therefore, the given vectors are linearly dependent. Linearly independent. Okay, this is the concept of the linearly independent and dependent. Okay, for the same concept with the alternative method, that is if rank of A less than n, then the given vectors are, okay, linearly dependent. If rank of A is equal to n, then the given vectors are linearly independent. Okay, for the same concept I am using with the alternative method for that. Rank of A less than n. N means number of unknowns in the given vectors. Okay, from that, if the two are less than, the given vectors are linearly dependent. If rank of A is equal to n, then the given vectors are linearly independent. This is alternative method for finding the vectors are linearly independent and dependent. For that, how we are finding the rank of A? By using echelon form. First we have to find rank of A. If it is less than of number of unknowns in the given vectors, okay, that is called as if the two are less than means there, for finding rank of A, use echelon form. Okay, echelon form. What is the form of the echelon form? In the echelon form, only we are applying the row operations. From the row operation, we have to reduce the matrix as upper triangular. What is upper triangular? Upper triangular means below the diagonals are zeros. Okay, already we discussed in the last classes. Okay, for that same concept I am using for finding linearly dependent or independent vectors. For that echelon form, first you have to find by using echelon form. For find, why you are using echelon form? For finding rank of a matrix. For that any matrix, for that square matrix or rectangular, we have to reduce the matrix as upper triangular matrix with respect to the row operations. There, after reducing as the upper triangular, then we have to consider the number of non-zero rows. Number of non-zero rows is equal to the rank of a matrix. That rank is less than of n, then the given vectors are linearly dependent. Or else, for the same concept with for finding the rank, if the rank of A is equal to n, then the given vectors are linearly independent. Okay, this is alternative method for finding linearly independent and dependent vectors. Or else, if linearly dependent, what we discuss now, this is equal to det A is equal to 0, there det A not equal to 0. Now we discussed the topic with determinant of A is equal to 0 and determinant of A not equal to 0. If det A is equal to 0 or rank of A less than n, the given vectors are linearly dependent. If rank of A not equal to 0 or rank of A is equal to n, the given vectors are linearly independent. Okay, now we are discussing two questions from the topic. For the first one, 1, 2, 3, 3 minus 2, 1, 1 minus 6, 5 minus 5 from a linearly dependent. It is linearly dependent, already we proved. Then that linearly dependent means det A is equal to 0. For the second question, we verified x1 is equal to 2 to 1, x2 is equal to 1, 4 minus 1, x3 is equal to 4, 6 minus 3 are linearly independent. For this, we proved det A is not equal to 0. Therefore, the given vectors are linearly independent. Or else, alternative method for that, rank of A less than n for the linearly independent, and the linearly independent means rank of A is equal to n. This is the concept for finding linearly independent and dependent vectors. Thank you. Thank you for all. Next class, we will discuss with some other methods from the second unit. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.